record this. All right. So when we look at these three examples, examples C, D, and E from the other day, this first example, I notice we can factor by GCF, greatest common factor, because 3 and 6 have a common factor, and I have x's in both places. So I'm going to factor out a 3, because 3 can go into 3 and 3 can go into 6. I'm also going to factor out an x because I have an x here and two x's here. All right, 3 divided by 3 is 1. I had two x's, but I've removed one of the x's, so I have one x left there. Minus 6 divided by 3 is 2. And then x, remove an x, leaves no x's behind. So now I'm going to set this equal to 0 just like we did. And now I'm going to take each of these parts and make them equal to 0. 3x equals 0. 1x minus 2 equals 0. Well, this first one's pretty apparent. The only thing x could be is 0 because 3 times 0 is 0. So x is 0 here. Over here, I'm going to add 2 to each side. 1x equals 2. Divide by 1. And my second 0 is at x equals 2. So there's my two zeros for this equation. So if we were to draw a graph of this, my parabola would cross at 0 and 2. So that's what we're figuring out, remember. We're using this without having to make a graph to figure out where my parabola crosses the x-axis. All right, the next two examples are a little bit trickier because we have to go back to that method where we had to do a times c. So this one, first of all, is not even in standard form. This 11x needs to move over here with all this other stuff. So remember, algebraically, the only way we can move things is by using symbolic methods. So I'm going to subtract 11x from each side. So 11x minus 11x is 0 equals, you'll notice this is an x to the power of 2. This doesn't have an x, and this has a regular x. None of these are like terms, so I can't combine any of the numbers. So we're just going to say 2x squared minus 11x plus 14. Now we're in standard form. So remember, when we have a number in front that's bigger than 1, we have to do a times c first. So 2 times 14 equals 28. So what I'm looking for now is things that multiply to 28 but add up to negative 11. So we multiply to 24 but add up to negative 11. And in this case, it's going to be 8 and 3, and they're both negative. Negative 8 times negative 3 is positive 24. Negative 8 plus negative 3 is negative 11. So now what we're going to do is we're going to split this middle term into 8 and 3. So this becomes 2x squared minus 8x minus 3x plus 14. So all I did is I split the 11 into 8 and 3. Now we have to factor by grouping. So I'm going to split this problem in half. On the left side, my greatest common factor is a 2. And then I'm left with an And I can take an x out, and I'm left with x minus 4 here. And over here, we're left with, can 3 and 14 be factored? It can't. So what do we do if we can't factor it? This is going to be tomorrow. Quadratic formula. We have to use the quadratic formula tomorrow on this one. So that's as far as we can go on that problem. Because 3 and 14 we can't factor by grouping on this one, as it turns out. All right, let's move down to E here. So we're going to do the same thing. Luckily, this one's already in standard form. So 0 equals 2x squared plus 12x plus 18. So we're going to do A times C. 18 times 2 is 36. So I'm looking for things that multiply to 36 but add up to 12. What multiplies to 36 but adds up to 12? Any ideas? 6 and 6. So this is going to become 2x squared plus 6x plus 6x plus 18. So again, all I've done is I've split this 12 into 6 plus 6 because I know that it will factor out this based on the x method down here. So now we're going to factor each side. Over here, we have 2 in common. So if I factor out a 2, and then I have at least one x on each side, 2 divided by 2 is 1. There would be 1x left. There were 2, but remember we pulled 1x out front, so that leaves 1x behind. Plus 6 divided by 2 is 3. There was an x, but it's been pulled out, so there's nothing left there. Over here, 6 and 18 is a factor of 6. 6 divided by 6 is 1x. 18 divided by 6 is 3. So remember from when we did quadratics previously, it's really important that when we get to this stage, the two things in the parentheses should match. And when they match, I can actually factor one of them out by grouping, 1x plus 3. And then what I'm left with is these two numbers, 2x plus 6. And remember, this is still equal to 0. So now I'm going to set each part equal to 0. 1x plus 3 equals 0. 2x plus 6 equals 0. And we're going to solve each part. So all I did is I took these two things down here, and I set each of them equal to 0 over here. So we're going to undo a plus 3 by subtracting 3 on each side. 1x equals negative 3. I can get rid of the 1, and my first 0 is at negative 3. Here, I'm going to subtract 6 from each side. 2x equals negative 6. And I divide by 2. X equals negative 3 again. Since these are the same, the only x-intercept is at negative 3, 0 on this one. That was a lot of steps, right? All right, we're going to do one more example. One more example. All right. 5x squared plus 18x plus 9 equals 0. So again, remember we start off by doing a times c because I have a number in front. So 5 times 9 is 45. So I'm looking for things that multiply to 45 but add up to 18. And I know that's going to be 15 and 3. 15 times 3 is 45. 15 plus 3 is 18. So I'm going to rewrite this equation, but instead of 18, I'm going to break this 18 into 15x and 3x. So I have 5x squared plus 15x plus 3x plus 9 equals 0. Now we're going to factor by grouping, by splitting the problem in half. I like these compatible numbers the way this worked out because 5 goes into 15. So I know I can factor out a 5, and then I'm going to factor out 1x. So 5 divided by 5 is 1. I had 2 x's here, but since one of the x's has been factored out, there's only 1 x left inside the parentheses there. Plus 15 divided by 5 is 3. And then the x here, there was only one of them, and since I factored it out, it's gone now. Plus, over here, I'm going to, same thing. I have nice compatible numbers. 3 goes into 9, so I'm going to factor out a 3. 3 divided by 3 is 1x plus 9 divided by 3 is 3. So again, my parentheses are matching, which is a good sign. When the parentheses match, that means we did it right. All right. So 1x plus 3 is my first parentheses. My second parentheses will be 5x plus 3. So I factored it out. So to find the zeros, I'm going to set each thing equal to 0. 1x plus 3 equals 0. 5x plus 3 equals 0. And we're going to just solve each of these equations. Now, just by looking at this, I can tell we're going to end up with some decimals here, but that's okay. This first one's all right. Take away 3 from each side. My 3's cancel, and I'm left with 1x equals negative 3. Divide both sides by 1. My first 0 is at x equals negative 3. Over here, I'm going to subtract 3 from each side, and I get 5x equals negative 3. When I divide both sides by 5, negative 3, I got to use my calculator to help me out here. Negative 3 divided by 5 is 0.6. So my second one is at negative 0.6. So there's my two zeros.